All right, so the questions on page 13 are very similar to number 19 in the sense that they don't give you a ratio, but they do give you an ordered pair. So let's look at the fact, and let's that they give you negative 15, comma 8. So I know that that would be in the second quadrant. And the coordinates of that point would be negative 15, comma 8. So what that means is from the origin, I've gone to the left 15, and I've gone up 8. So remember, we are going to be looking for our reference angle. So our reference angle we're going to find right here between the terminal side and the x-axis. That's that space right in there. And we always drop a perpendicular from that terminal side to the x-axis. So I know that this side is 15 and this side is 8. And I can find the hypotenuse by doing Pythagorean theorem. So 8 squared plus 15 squared equals c squared. So that's 64 plus 225 equals c squared. And then if I add those two, I'm going to get 289 equals c squared. Take the square root, and that will be 17. So I know the hypotenuse is 17. Okay, so they're asking for the numerical value of the cosine of A. Okay, so cosine, if you recall, is adjacent over hypotenuse. So my adjacent side, I'm going to go to that reference angle. Adjacent will be 15, and the hypotenuse is C, which we know is 17. So 15 over 17. Now let's take a look at the fact that our triangle's in the second quadrant. And we should know, all students take calculus. Sine is the only thing that's positive in that second quadrant, so that makes this value negative 15 over 17. Number 21, so we have the point 4, negative 8. Good, this one's a little bit different, yay. So I'm going to go to the right 4, and then I'm going to go down 8, and there would be my point. Okay, so let's just talk about this for a minute. So I went from the origin, I went over to the right 4, and I went down 8. So the coordinates of that point, I'm just going to write that, is 4, negative 8. Okay, now remember that I always take a point on the terminal side and I always draw a perpendicular to the x-axis. So in this case, I need to go straight up to that x-axis and draw myself a perpendicular. Never ever should we go from this point to the y-axis. Remember, it always goes to the x-axis. Okay. All right, so my reference angle, my angle comes all the way around there. That's your angle x. And then your reference angle is this angle between the terminal side and the x-axis. I'm just going to shade that in a little bit for you. So now I know that my horizontal side here is 4. And this is a distance of 8. I understand it's in the negative direction, but we don't really label the side of a triangle a negative. The negative just refers to the fact that I went down 8 units. All right, so then if I want to find the hypotenuse, which I'm going to label that C, I'm going to do 4 squared plus 8 squared equals C squared. So that's going to be 16 plus 64 equals C squared. So C squared is going to equal 80, so C will be the square root of 80. Now I know that the square root of 80 can be broken down to 16 and 5. So C is equal to 4 radical 5. So they're asking me for tangent. And tangent is the opposite over the adjacent. So I'm going to go to that reference angle again. Here's my reference angle. Opposite is 8. And the adjacent is 4. Well, Did I really even need this then, huh? Womp womp. That was a waste of time. But anyway, so because we don't really need it, because we know that the tangent is the opposite over the adjacent. Had I been smart, I would have seen that I had the opposite and I had the adjacent, and I could have quit while I was ahead. But anyway, so I know then that the tangent of x will be the opposite over the adjacent, and I'm going to simplify that a little bit, and that's going to be 2. Now, is that positive 2 or negative 2? There's your $1 million question, because all students take calculus. So I am in the quadrant where only cosine is positive, and I do not have cosine there, so that value should be a negative 2. There's your answer. Number 22, so they give us the point 2, negative 1. So 1, 2, negative 1. So there is my point. I'm going to draw myself a terminal side. I'm going to call that 2, negative 1. All right, so my angle really is all of this. And then my reference angle is the angle that's formed by the terminal side and the x-axis, which is this angle right in there. Now remember, I always draw a perpendicular, and it always goes to the x-axis. So I go from this point up to the x-axis, draw myself a right angle. So I know that the length of this side here is 2 because I went out 2, then I went down 1, and even though this is down 1, it's a distance of 1. Yes, it's in the negative direction, but this is still a distance of 1. So let me label those sides. Okay, so this side is 2, this side is 1. All right, now I'm going to get smart on number 22 and not do extra work if I don't need to. So let's just see. They want sine, and I know that sine is opposite over the hypotenuse. So let's go back here and look. Here's my reference angle. I do have the opposite, but I do not have the hypotenuse. So I actually have to do the Pythagorean theorem this time. So I'm going to do 2 squared plus 1 squared equals c squared. And this is my c, right? So that's 4 plus 1 is c squared. So c squared is 5. And that means that c is the square root of 5. Alrighty, so let's see. We want the sine of theta, right? So sine theta equals, here we go, here's my reference angle, opposite over hypotenuse. So my sine theta is going to be 1 over radical 5. But I cannot have a radical in the denominator, remember that. So I'm going to rationalize that by multiplying the numerator and the denominator by whatever it is that you want to get rid of, which in this case is the radical 5. So that is going to give me sine theta equals radical 5 over 5. Okay, last thing though, let's check the sign. So all students take calculus. I am in the 4th quadrant. The only thing that's positive in the 4th quadrant is cosine. And I don't have cosine, I have sine. So my answer is negative radical 5 over 5. 23. The terminal side of an angle theta passes through the point negative 1, 0. Oh, this one's interesting. Isn't this point right here negative 1, 0? Which means angle always starts at the positive x-axis, and we rotate, rotate, rotate right to that point. That's what they're saying. So determine the measure of this angle theta. Well, isn't that 180 degrees? Haha, that's nice and easy, isn't it? That's 180 degrees. We don't need to do anything else other than that. All right, so 24, this one's a little bit different. So what we have here is we have a circle centered at the origin, and the radius is 10. All right, I'm not going to draw the best picture in the world, but I will do the very best I can. All right, that looks kind of awful, but now the radius is 10 of that circle. The terminal side of an angle theta intercepts the circle in quadrant 2 at point C. So this is what I'm going to do. Here's a radius, right? And I know that that radius is a length of 10. And then they said that we have a terminal side of an angle theta intercepts the circle in quadrant 2 at point C. So I'm going around, 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 around till I get to point C. And this is my angle theta. Okay, now it says the y-coordinate of point C is 8. Now I'm sorry that I'm doing this, I kind of can't fit it, so I'm going to put the coordinates of C over here. And they said that the y-coordinate is 8. So doesn't this 8 mean I'm going to start here at the origin. I'm going to go over some distance. I don't know how far that distance is because that distance is an x value and they didn't give it to me. But I do know, however far I go, after that, I'm going up 8 because that's the y value. So this distance right here is a distance of 8. Does that make sense? Okay, so then what I'm going to do is I'm going to drop my perpendicular, just like that, and I know that distance is 8. All right, now that is a really ugly picture. Let me just kind of redraw it to make it look a little neater. I'm sorry. So really, if I take it out of context of that circle anyway, here's my 10 and this is my 8. And the coordinates of this point here, which are C, is something, comma, 8. Okay, does that look a little better? All right, now what they want you to do is find the value of cosine. And I know that cosine is the adjacent over the hypotenuse. So I'm going to, just like always, I'm going to look at that reference angle, which is going to be this angle right here. And I am going to figure out the adjacent, which would be right here. I don't know that. And the hypotenuse, which is 10. So, well, if I don't know a side of a right triangle, I can do the Pythagorean theorem, right? So a squared, and I'll refer, I'm referring to the side that I'm missing, which is my adjacent, that's a, plus 8 squared equals 10 squared. So a squared plus 64 equals 100. Subtract over the 64, and I get a squared equals 36. So a has to be 6. Okay, so we want to find the cosine of theta, and that's the adjacent, which is 6, over the hypotenuse, which is 10. We can go a step further if we want, or we should, and we're just going to reduce that. So that ends up being 3 over 5. Now remember, lastly, we always check the quadrant, and I see that I'm in quadrant 2. And remember, in quadrant 2 here, actually, I'll put it here, but in quadrant 2, all students take calculus, right? So this is the S quadrant, so the only thing that's positive there is sine, and I don't have sine, so I need to negate that value, and there's your answer. So 25 is very similar to number 24. I'm going to see if I have any better luck if I actually draw the circle first. So, oh my goodness, I just stink at drawing circles, sorry about that. So here's my disgusting circle, and they're saying that I have an angle in the 3rd quadrant. All right, so let's do this. 3rd quadrant. So I'm going to start here on the positive x-axis. I go around, 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 around to the 3rd quadrant. There we go. And the angle terminates in the 3rd quadrant at point M. So there's my terminal side. Remember, I'm going to draw a perpendicular to the x-axis. And they tell me that the radius is 12, so I know that that is a 12. And they tell me the x-coordinate of M is -6. Well, if I want to find the coordinates of this point, it's how much I go in this direction, then how much I go in this direction. So the x-coordinate would be this value right here. And they're telling me that's -6, but the length of it, because it's a triangle, the length of that side will be 6. Okay? All right. So then they want us to find tangent. And I know that tangent is the opposite over the adjacent. So let's look at, here's my reference angle right here in this corner. Right, and let's see. So from this reference angle here, my opposite side is this side right here that I don't know. And my adjacent is 6. So I have to do Pythagorean there. Alrighty, so I have 6 squared plus b squared equals 12 squared. And this is the b that I'm referring to. All right, so we got 36 plus b squared equals 144. Subtract that 36 over, and that gives me b squared equals 108. So then b is the square root of 108. There's got to be a perfect square in there, isn't there? So that would be 36 and 3. So then b would equal 6 radical 3. All right, so let's find the tangent of theta. So that's going to, again, let me just reiterate again. Here's my angle. The opposite, which would be my 6 radical 3, over the adjacent, which would be my 6. So 6 radical 3 over 6. Now, it is absolutely okay to have a radical in the numerator of a fraction. You just can't have it in the denominator of the fraction, so we're good. I would probably cancel these guys out because 6 over 6 is 1. So then I have tan theta equals radical 3. Now let's see if we have a positive radical 3 or a negative radical 3. So all students take calculus. Tangent is positive in the third quadrant, and that's exactly what I have. So I don't need to do anything but box off my answer.